Hi, this is Girish. I've done a project on automated plant aeration system under the unit name of analysis of discrete time signal, subject name signals and system, and subject faculty J. Jagan Babu sir. Overview of the project. Basically, this is a soil moisture monitoring system which detects if the moisture content in the soil is above or below a certain satisfactory threshold value. If it gets below a certain critical point, it is a time to water the plant until the soil surrounding the plant is moist enough. An arrangement of a DC motor and a servo motor is used to control the watering mechanisms. It's a brief intro of the topic. Uh, Before we start with the project itself, let's see what led us to take up this challenge to make this automated warning. In the 20th century, climate change and depletion of resources have become a major issue to deal with. With ever-growing population and increased demand for natural resources, we find ourselves in the middle of a crisis which calls for immediate action. Sustainable development must be adopted by each one of us, both on a personal level as well as a socio-industrial level. Conventional irrigation methods uses a lot of water and needless to say, a lot of water is wasted on a daily basis. With the help of advanced methods of irrigation, which should ideally use just the correct amount of water needed for the plants. We could save a considerable amount of water with the help of the soil moisture sensors. We could use just right amount of water we need for irrigation, and that is the motivation of the project. Equipment used: Arduino UNO soil moisture sensor module, motor driver IC L293D, servo motor, home motor, 12-volt DC adapter, and Vero board wires and jump force. This is the basic circuit diagram of my project. The main elements of the circuit are Arduino soil moisture sensor, motor driver IC L293D, servo motors, and DC motors. Well, Arduino is an open source microcontroller based for building a digital devices and an interactive object that can sense and control an object in a physical world. The board features RS-232 serial communication and interface, including USB on some models for loading programs for personal computers. Okay, this is the basic structure of Arduino board. Soil moisture sensor module. The soil moisture sensor measures the volumetric water content in the soil. The soil moisture sensor measures the volumetric water content indirectly by using some other property of the soil, such as electrical resistance, dielectric constant, or interactions with newtons as a proxy for the moisture content. The soil moisture sensor uses a capacitance to measure the dielectric permittivity of the surrounding medium in soil. In dielectric permittivity is a function of the water content. The sensor creates a voltage proportional to dielectric permittivity and therefore the water content of the soil. The basic model of the soil moisture sensor model. Okay. Motor driver IC2 ICL293D is a motor driver integrated circuit which can control a set of two DC motors simultaneously, which uses a 5 volt for its own power and external power source is needed to the driver motors. A special feature of this IC is controlling the direction of rotation of the motor, which is done with the help of an edge bridge. A motor driver is basically a current amplifier which takes a low current signal from the microcontroller and gives out a proportionally higher current signal which can control under driver motor. Servo motor is a rotatory actuator that allows for a precise control for angular or linear position, velocity, and acceleration. It consists of a suitable motor coupled to sensor for the position feedback. Here, the Arduino controls the rotation by specifying the exact angle of a rotation. Well, DC motor is any of a class of electrical machines that converts a direct current electrical power into a mechanical power. The most common type of DC motors rely on the force produced by magnetic fields. DC motor speeds can be controlled over a wide range, either a variable supply or a voltage, or by changing the strength of a current in its fittings. Now let's get into the working. The soil moisture sensor continuously monitors the volumetric moisture contents in the soil and sends that information to the Arduino with the values lying in the range of 0 to 1023. If the soil moisture content goes below a certain point, which is decided by the threshold value given in the Arduino code, the Arduino signals the servo motor and the DC motor to start watering the mechanism. As soon as the Arduino decides the soil needs a watering, it tells the servo motor how much to rotate along with the water holding container. It is tightened to let the water flow. Remember in mind that all this while the pump motor, that is the DC motor, is running to maintain a steady and flow of water. This is the basic prototype of my project. From the above project, we have mainly built a prototype, but the advantage of this project are numerous. We can implement this technology in the real world. A lot of water can be saved. The world uses about 70% of fresh water for irrigation, and on the other hand, multiple yields of most crops by almost 2 times. So irrigation seems to be a necessary here. The best solution of now this is controlled usage of water for irrigation purpose. The purpose successfully filled by the project, and we can save a lot amount of water without any wastage. And this is the output of the project. Thank you.